Back again, question 5. Using the trapezoidal rule with 4 subintervals, which expression gives the approximate area under the curve y equals x e to the x between x equals 1 and x equals 3? So split it up, use your formula, and it should be pretty straightforward. Use the trapezoidal rule, 4 subintervals. So we've got 1 and 3, so we want to split up 1 and 3 into 4 parts. So we want to go from here to here, somewhere to somewhere. So we split it in 2. You're going to split this in 2 and split this in 2. So they're your intervals, 1, 2, 3, 4. So each of these is your b minus a. So you would do 1.5 minus 1 over 2. The first one, so you put in the first thing, which is your a, 1, into there. So you're going to get 1 e to the 1 plus, put in 1.5, 1.5 e to the 1.5 plus, and then keep going. Now you know that this bit's going to stay the same. 1.5 take away 1 is a half. A half divided by 2 is a quarter. So you know this term all the way down, if we write the next one, 2 minus 1.5 over 2, it's going to be the same. It's always going to be, in this case, it's always going to be a quarter. So when you look at your answers here, you can see these two are a quarter, these two are a half, so these two are definitely wrong. So you don't even have to look at those. Now all you need to do is figure out whether this term's a 3 or a 6. And again, that's pretty straightforward. So if you write your second term, we're going to get 1.5 e to the 1.5 plus 2e to the 2. Okay, because you're just putting in these values, you're putting in the 2 this time, 2e to the 2, and that's your second term, because that's your fb, yep, the function of b. And it's going to continue, so you can tell that this pair and this pair, all the way down, are going to join together. So you're going to get 1 on the first one, well, they're all 1s. 1.5 plus 1.5 is 3, e to the 1.5, so we want 3 e to the 1.5. Now we already know these are out, so b is going to be your answer. You keep going down, 2 plus 2 is 4, which is the same, and the next one's going to be 5, which is going to be 2.5 plus 2.5 is 5. So b is your answer. Question 6. What is the value of the derivative of y equals 2 sine 3x minus 3 tan x? Should be pretty straightforward. Just do 2 derivatives, one at a time. What's the derivative of sine x? You should know it. It's cos x. You can look it up on your formula sheet. So y dash equals 2 cos 3x. Now the 3 there, because you're going to do the derivative of that as well, that 3 is going to come in front, so you're going to get 3 times 2 there, minus derivative of tan x is sec squared x, so sec squared x. There's nothing there except a 1, and the 3 will stay the same. So that's your derivative, that's 6 obviously. Now we want x equals 0, so we're going to put in 6 cos 0 minus 3 sec squared 0. So you can actually just put that in your calculator. The only problem is you probably might not have sec squared on your calculator, but what's sec? Sec's 1 over cos. So you can actually just go and, or you can look it up, or just by drawing it, by knowing your diagram. Here's your cos curve. And there's cos at 0. Cos at 0 is 1. So we know that cos 0 is 1. So this is going to be 6 multiplied by 1 minus, well, what's sec squared? 1 over cos. So 3 over cos squared 0. And again, we know cos squared 0 is 1. So it's going to equal 6 minus 3 over 1. 6 minus 3 is 3, and you're done. Back again, question 7. The diagram shows the parabola y equals 4x minus x squared, meeting the line y equals 2x at 0, 0 and 2, 4. And it gives you the diagram. Which expression gives the value of the shaded region? and you've got a bunch of integrals. So if you integrate, you're finding the area under the curve. So these ones are a combination of these two equations. They've done a tricky thing. They've put this equation up the top and this equation down the bottom, which is exactly the opposite of what you want, because you want the area under this curve, take away the area under this line. Okay? So if you have, I'm drawing it straight. There's the curve, and we want, let's say there's 2, 4. We want this area under here, this whole area. So that's the area under the curve, which is down the bottom. So just notice that. Also, they've added in this point here, 4, 0, just to throw the student off. There's no reason for it. I mean, why is it there? You don't use it. And they've put in these 4 and 0 here to try and trick the student. So these two are clearly wrong because you want about the x-axis. That's 2. You want between there and the x-axis. And that's 2. So we want from 0 to 2. Okay? So these two are clearly wrong. You would only have the 4 if it was about the y. So if you're going across here, because that point there is 4 if you're going about y. But we're not. We're going to x. Okay, so you're looking for the x value. That's x, that's y, just in case you forgot. Okay, and then we're going to take away that one. So if we take away the line, you're going to take all this away. And that will leave us with our answer. So we want the curve, which is 4x minus x squared, and we're going between 0 and 2, which you already said. And we're going to take away the line, so minus 2x, and that makes it pretty obvious. 4x, take away 2x is 2x, again we're sticking between 0 and 2, minus x squared, and that's our answer. So which one is it? 2x, take away x squared. The answer is B. G'day again, question 8. The diagram shows the graph of y equals e to the x, brackets 1 plus x. It gives you a nice little graph passing through 1 and minus 1. How many solutions are there to the equation e to the x, brackets 1 plus x equals 1 minus x squared? 2 ways to do it. 1, do the algebra. 2, do the graph. So we'll do both ways and see which way you would have picked. Okay, 1 is to do the algebra, so we'll just solve e to the x, 1 plus x equals, well, first step is realise what that is. That is the difference of 2 squares. That's 1 squared, take away x squared. Even though it doesn't say the squared, that's something for you to realise. So you have to go 1 minus x, 1 plus x, and because you can cancel that out, you've instantly got a solution. So one of your solutions is x equals minus 1. Okay, so let's wipe that out and then look at the second solution. Okay, so now you've got e to the x equals 1 minus x, and it's going to take a little bit of perception. 1 minus something is going to give e to the x. There's nothing really you can press on your calculator other than realising, if I put in 1 in there, 1 minus 1 is 0. Sorry, if I put in 0 in there, 1 minus 0 is 1. That is going to equal 1. And I put in 0 there. Well, anything to the 0 is going to equal 1. That 0 is going to be a solution. So x equals 0 is a solution. But that takes a bit of perception. It doesn't just happen off the top of your head. So algebraically, I think that's a bit tricky. In an exam, you're in an exam, you think, they're the 2 solutions. So your answer is there are 2, but there's a simpler way to do it. I tell you this is a graph, and you're meant to pick that up. You're meant to pick up, that's a graph. Here's a graph. What does that graph look like? And that should be pretty obvious. Well, let's quickly draw y equals 1 minus x squared. What does that graph look like? It's got an x squared, so it must be a parabola. So parabola up, positive, If that was a positive, it would be up, but we've got it negative, so it's going to be down. Okay, sad face. What does the 1 mean? Well, if I put in 0 there, the 1 means it crosses the y-axis at 1. So you're going to have a parabola that passes through 1. And you don't really have to work out any other points on this other than knowing that it's going to go down there, it's going to go down there. So I'm in the HSC, what am I going to do? I'm going to draw this straight on top of that. I'm just going to go, right, I don't care where it goes through, I don't have to figure it out. We know if we figure it out, it actually works out to work that, but you don't have to figure that out. All you have to know is it passes through there and somewhere over here. So 1 solution and 2 solutions, and your answer's 2. And that would be the quickest way to do it. G'day again, question 9. So question 9 is probably your hardest multiple choice question. A particle is moving along the x-axis. The graph shows that its velocity in v meters per second at time t seconds. And it gives you this graph. It tells you when t equals 0, displacement equals 2 meters. What is the maximum value of the displacement x? 2 ways to do it. I would suspect they would expect you to do the working out, being question 9. But there is a faster way to do it. So I'll do the working out, which is what I think they would expect you to do, and then I'll show you a faster way. Okay, so what is the equation of this line? This is the velocity equation, so let's figure it out. Equation of a line, y equals mx plus b. M is your gradient. What's the gradient of this line? Well, rise over run. It goes up 8, across 4, it's going down, so it's a negative gradient. So m equals minus 8 over 4, which equals minus 2. So that's the gradient of that line. What's b? So that's the gradient. What's b? Well, that's your y-intercept. Well, where does it intercept? In this case, it intercepts at 8. So the y-intercept is 8. Now I've written it as y and x's, we've got v and t. So let's change it so it looks like the proper equation. So v equals minus 2 t plus 8. And that's your velocity equation. What's velocity? Well, it's dx to t. So dx to t equals your velocity. If you differentiate your displacement, you get your velocity, which is what this is. And we're looking for what is the maximum value of the displacement. So if you're given the velocity, we're going to integrate to get that. So let's integrate that. So we'll get x equals, integrate minus 2t plus 8. Raise that to a power is t squared on 2. So minus t squared on 2 plus 8t plus c. So that's your equation. We can simplify that by just minus t squared. So this is your displacement equation. I shouldn't use a small x there, should I? Your displacement equation is minus t squared plus 8t plus c. What do we know about this equation? Well, when t equals 0, displacement equals 2. So that's 2, 0, 0. So let's go 2 equals nothing plus c, so c is 2. So that number there, or that letter there, is going to be 2. So the displacement equation is therefore x equals minus t squared plus 8t plus 2. There's our displacement equation. What is the maximum value? How do you figure out the maximum? Well, you differentiate it and put it equal to 0. If you differentiate that, you get the velocity equation, which we started with. So let's put that equal to 0 and figure out what t is, and then put t into there. So let's put this equal to 0. So if we're going to put that equal to 0, minus 2t plus 8, you can pretty obviously see the answer. If I move 8 over to this side or 2t over here, you're going to get t equals 4. So minus 2t equals, move the 8 across, minus 8 divided by minus 2, and t equals 4. So that is going to be when the maximum occurs. Differentiate that, get that, put it equal to 0, get our value, put our value in there, so we get minus 4 squared plus 8 times 4 plus 2. Minus 4 squared is minus 16. 8 times 4 is 32. Plus 2 minus 16 plus 34 is 18. And that's your answer. There's a quicker way. Graph shows the velocity. We want displacement. What is displacement? Well, displacement is integration. What is integration? Integration is the area under the curve. So let's think about it. What's the area under this curve? It's a triangle. What's the area of this triangle? Well, half the base times the height. Half the base, so half times 4 times 8. Half of 4 is 2. 2 times 8 is 16. So that equals 16. That's the area under the curve. Add that first piece of information to when t equals 0, displacement equals 2. 16 plus 2 equals 18, and you get the maximum displacement. Now, doing it that way, of finding the area, adding the displacement, is quicker, but it requires a bit more practice and intuition. This is probably the way that you would be expected to do it, but if you keep that in mind and you practice looking at graphs enough, that's a much quicker way to get through the question. So either way, your answer is D. G'day again, last multiple choice question. Question 10. The diagram shows the area under the curve y equals 2 on x from x equals 1 to x equals d. So here's the area under the curve. What value of d makes the shaded area equal to 2? How do you find the area under the curve? You integrate. So we're going to integrate this. If you integrate anything over x just on its own, because we can take the 2 out the front, make it look a bit more obvious. And that's actually on your formula sheet. Integral of that is log x. So that's going to equal ln x plus c, but it's not plus c because we're doing in between 1 and d. So if we go log x, or 2 log x, in between 1 and d, you're going to get 2 log d minus 2 log 1. Well, what's log 1? You can do that on your calculator. That equals 0. So this bit just equals 2 log d. Now we want this area under the curve to equal 2. So I want that to equal 2. So if this bit equals 2, then this must be 1. So log d must equal 1. Well, log of the same thing, because this ln is log base e. If the base and the number are the same, it equals 1. So in this case, our answer is E.